I'm Nan Chaudhary, and I'm a high schooler at Monte Vista. So today I want to go over a topic commonly known as Hopital's rule, which you'll discover in calculus. It's going to be part of the limit section near the beginning because this is a very important thing, and you're going to find it on a lot of tests, whether it's your AP calculus test or the SAT exam. So why don't we head right on into it? So Hopital's rule is a quite famous rule, and when you're taking a limit with a numerator and a denominator, and your limit as x approaches to c is equal to 0 by 0 or positive plus or minus infinity by infinity, this rule is applicable. But what is this rule? This rule is simply stating this. So the limit, so if this condition is met, because this is a condition, if this condition is met, you can use this. So then you could just simply shift it down to limit as x approaches to c. This part stays the same. But what you're going to do is you're going to take the derivative of the numerator alone and the denominator alone. You're not actually going to be taking the quotient rule here. So what you're going to do is it's going to be f dash x by g dash x. And you're going to take the derivative of both of them individually. Now, I'm going to go over some problems which require you to use Hopital's rule. So why don't we get started with the first one? So problem number 1. And so there is an established formula which is used for the problem I'm about to give you, but in some way this is kind of me proving it using Hopital's rule. So the problem is limit as x approaches 0 of sine of x by x. Now, if you guys know the formula, you know sine x by x, I mean the limit as x approaches 0 of sine x by x is going to equal to 1. But the question is, how would we do that? Now, using Hopital's rule, I can show you. So, let's first check that the condition is met, that if you would plug in c, it's going to be 0 by 0 or infinity by infinity. So, if we use direct substitution here, you're going to get sine of 0 by 0. Now, sine of 0 is equal to 0, and you're going to divide that by 0. So the condition is met. You can use Hopital's rule, commonly denoted like that. So, we're going to use Hopital's rule in this problem. So what's going to happen, we're going to write, because remember, nothing changes about this. Limit as x approaches to 0 of the derivative of sine x. These are common trigonometric derivatives that you should know. The derivative of sine x is cos x, cosine of x. Cosine of x, and the derivative of x is 1. And if you were to simplify this, this would become limit as x approaches to 0 of cosine of x. Now, because after you use Hopital's rule, you have to use direct substitution. And let's say even after direct substitution again, what happens is you get 0 by 0 or infinity by infinity again. By the way, these two forms are known as indeterminate form. That's the more mathematical term for it. So let's say after Hopital's rule, this becomes into indeterminate form again. What's going to happen is you can use it again and again and again as long as this condition is met. When this condition is not met, you can't use it anymore. So, limit as x approaches 0 of cos x. So what we're going to do here is we're going to use direct substitution again, just to check. And if you do cosine of 0, we know that that is equal to 1. And again, this is basically how this formula was derived, using Hopital's rule. And that's very common. Common thing you should know, sine x by x is equal to 1. This is just like a kind of a proof. So now we're going to go over another problem. We're going to go over another problem. And this problem will also have to require you using Hopital's rule. Limit as x approaches to infinity of ln x by x. Now before I go over it, I would really recommend that you try this on your own. Pause it here and try it on your own. But hopefully you did that, and why don't we just head right on into it. So just going straight from direct substitution to see if our conditions will be met or not, we're going to input this value in, ln of infinity by infinity. Now ln of infinity is infinity, and it's already going to be divided by infinity. So in that case, our form is in indeterminate form. So now what we're going to do here is use Hopital's rule. Hopital's rule. So what Hopital's rule tells us is derivative of the numerator divided by the derivative of the denominator. So the derivative of ln x is 1 by x. So remember, you're going to keep this part the same. Limit as x approaches to infinity of 1 by x divided by, because 1 by x is the derivative of ln x, divided by x. And the derivative of x is 1, and we know that using the power rule. Now if we were to simplify this, 1 by x divided by 1, anything divided by 1 is whatever's on the numerator. So limit as x approaches infinity of 1 by x. Now if we were to plug in the value, you get 1 by infinity. Now you guys may think, oh, this is unsolvable, it's 1 by infinity, you can't do anything. But just remember, any number divided by infinity is going to equal to a very, very, very large number. Very small number. Because you're dividing it by such a large number. So this is actually going to head towards 0. Because the closest thing, we kind of approximated in this case where it's equal to 0. And so that's Hopital's rule. I hope you guys understood. I hope you guys enjoyed the video. Please hit the like and subscribe button if you guys haven't already. And thanks for watching. Bye.